Hello everyone, welcome back to my channel InfoSec Lab, and this is Hui. Today I'm gonna be starting the series of TryHackMe attacking and defending AWS services. Now keep in mind that this is a special path that you have to pay extra money to get access to the material and resources. And because of that, throughout the video I'm gonna be reading the whole material for you guys. So for those of you who don't have access to such materials, can actually follow through all the activities and concepts of the path. Now, without further ado, let's get started. The very first one is AWS 101. The learning objectives. This room is intended to provide users who are not familiar with cloud technologies an insight into some of the cloud's unique characteristics. Students in the rooms will learn about how current cloud capabilities evolve from humble beginning at AWS and other early internet companies, why cloud technologies have changed and how individuals and corporations interact with IT infrastructure, how business non-tech benefits have helped drive cloud adoption, free resources and documentations that AWS has created for the public. This information will help you become familiar with AWS even if you have never ever used a single cloud technology. This task will help you understand the broader story arc of where the cloud has been, is, and therefore where the cloud may be going. Alright, let's get started. So this room are going to be beginner friendly, so even if you don't have any experience in cloud, you're more than welcome to actually take part in this room. Cloud enters the scene. On-premise model. Organizations have been hosting their own IT infrastructure in one form or another since the 1970s. But during the late 1990s dot-com boom, organizations began to have widespread business reliance on internet-connected services. To serve these needs, companies drastically expanded their data center footprints. As the data center business grew, it became common for third parties to manage data centers on behalf of their customers. The cloud. At first, the cloud often meant hosting servers in someone else's data center, rather than manage a fleet of servers running 24/7 with a bare-bone IT department at a small or medium-sized company. Organizations would offload this responsibility to a third-party provider who specializes in managing IT infrastructure. Eventually, providers developed custom software to manage the large fleets of infrastructures, networking gear, and servers that had been deployed. While perceptions persisted for some time that the cloud was just someone else's computer, this room is designed to cover some of the unique characteristics of cloud providers, and specifically AWS. What decade did the company start having widespread reliance on the internet-connected services? It's the 1990s. More scalable. Growing demand. Starting in the late 1990s, websites could not handle the traffic coming their way from ever-growing World Wide Web. As the 2000s started, a number of technologies came onto the scene to address these needs. First, there were content delivery network (CDNs) that would serve static content on behalf of a website. Then along came AWS EC2, a virtual machine service that would allow customers to deploy additional servers on demand. Involving approach. While originally a simple service designed for customers to leverage a pool of additional server capacity, the programmatic nature of EC2 deployment allowed developers to create automated scaling workflows that were the early predecessors of EC2 autoscaling. While third parties initially created autoscaling services, AWS released the official autoscaling feature for EC2 in 2009. Leveraging autoscaling. A customer can specify how to scale infrastructure in response to a wide variety of static and dynamic conditions. Though it may not seem significant, this change dramatically improved technology's team ability to manage operational costs and improve flexibility during change demand. Since EC2 and autoscaling, AWS has created a number of services that further enable scalability. Technologies that support cloud-native architecture are key components of AWS's strategy. While this training won't go in depth on cloud-native concepts such as containerizations or serverless capabilities, you should have a general idea of what these are and that they represent additional building blocks that help create highly scalable infrastructure. Alright, auto-scaling allows scaling any types of applications, containerized or non-containerized, and maintains application availability to meet customers' demands. Was easy to auto-scaling the first auto-scaling services in AWS? No, it wasn't. More reliable. Legacy on-premise pattern. Prior to the cloud, failover capabilities for data centers were often manual or highly customized for the technology stack of a particular organization. This often took the form of a primary or backup data center that were geographically separated, using a common virtualization infrastructure, VMware for example, that was replicated in both locations. However, organizations were forced to spend a substantial amount of time and energy trying to gracefully fail over between data center or risk a prolonged outage in the event of a primary data center outage occur, and fail over attempts to the secondary data center were unsuccessful. Furthermore, organizations had to maintain a backup data center and the eye-popping associated costs only for it to sit idle for extended period of time. The cloud pattern. AWS and other hyperscale cloud providers have a distinct advantage in reliability for a number of reasons. One key reason in AWS that runs a large number of data centers, which means that they can gather data and insights about the failure of the system that would not be feasible for most organizations with only one or a handful of data centers. Why specific numbers are not clear regarding the number of data centers, AWS claimed to have the 99 availability zones in over 31 regions at the time of writing. So what does it mean? Region. AWS defines a region as a physical location around the world where we cluster data centers. A region will be made up of one or more availability zones. These data centers can make up availability zones will all be located within 60 miles of each other in a given region. Though not every AWS service is available in each region, and some services are not bound to a specific region, AWS architecture is designed so that most services are available across a wide number of regions. Not all AWS services are regional, some global like Amazon Route 53, Firewall Manager, etc. Availability zones. An availability zone, or AZ, is one or more discrete data centers with a redundant power, networking, and connectivity in an AWS region. These separations mean that an outage of one of AZ due to lost power, networking issue, or ISP connectivity issues should not affect any other AZs. AWS further intends for availability zones to be key failover capability required by the customers. In fact, during this 2018 relevant AWS annual conference talk, the speaker highlights how AWS region services are designed to withstand AZ failures. While this perspective has been challenged by real-world experience, applications built on AWS are generally considered to be highly resilient if deployed in multi-AZ configurations. The above figure illustrates that a single region can contain multiple availability zones. So basically, a region can be US East or US West or Asia, and within those specific regions, you're going to be having multiple availability zones. Like if for those of you who have never used cloud technologies, then within each of the regions, you're going to be having like US is 1, US is 2, and US is 3. So those are the availability zones available within the cloud services. Now, I just explained right here. Now you can recognize an availability zones by on the letter followed by a region name when working with a virtual private cloud about resources. For example, US East 1 has the following availability zone. US is 1A, 1B, 1C, 1D, 1E, 1F. So these are the availability zones within the US East region. Naming conventions. Perhaps you have generalized AWS naming conventions from the examples above. For those who don't see the pattern, AWS name regions and availability zones are based on the common naming convention. For regions, names commonly start with one or a few different designations. AF for Africa, AP for Asia Pacific, CA for Canada, EU for Europe, ME for Middle East, SA for South America, and US for the United States. A cardinal direction, north, east, south, west, central, or a combination southeast, northwest, is appended to the abbreviations based on where the region is inside the geography of the region. US is for those data centers considered to be in the eastern USA. The convention follows with a numerical designations 1, 2, 3, 4, based on whether it is the first, second, third, etc. region within the geographic location. For example, AF South 1 is located in Cape Town, South Africa. It is a region on the African continent in the southern portion of that geographic area, South, and the first such region. There are other designations that are less common, such as US Gulf Cloud and those associated with AWS China, but the general naming conventions can provide you with helpful context as you use AWS. Answer the question, how close together in miles should an availability zone's data centers be? 60 miles. Next. Data sovereignty. On August 25th of 2006, AWS launched EC2 in the US East 1 region located in Northern Virginia. A short 15 months later, AWS launched a European version of S3 object storage due to the need of European customers to keep the data in Europe. This was the beginning of a common theme and an important concept to understand about the cloud technology. While customers in the US have enjoyed the benefits of AWS since the beginning, other countries may have data sovereignty laws or regulations that dictate which AWS region will host the company's technology assets, or even whether the associated data can be hosted on the cloud at all. At present, AWS hosts regions on every continent except Antarctica and in many key locations with data sovereignty requirements. Notably, AWS China is even a separate partition, AWS CN, which means that AWS China accounts were managed entirely apart from the other global AWS accounts. AWS also maintains a separate partitions for US Government Cloud, US Government Secret Data, AWS ISO, and USA Government's Top Secret, AWS ISO-B. Why these are the known AWS partitions? There are likely others, including internal AWS partitions. Latency. Beyond the hard requirements of data sovereignty, geo-distribution serves the dual benefit of allowing AWS customers to host internet-facing resources in geographic locations near where customers will be at the time of access. Even though data travels through fiber optic cables at nearly at the speed of light, latency can increase dramatically over physical distance. This is additionally important due to search engine considerations about site latency, where search engines are primarily the driver of traffic for many sites. Sites that consistently exhibit poor latency are unlikely to receive high search engine rankings. AWS customers may take advantage of geo-distribution in a number of ways, but one notable way is through the use of CloudFront, the AWS Content Delivery Network or CDN. CloudFront has over 275 points of presence, where a point of presence is a physical location serving internet traffic. CloudFront enables intelligent traffic routing and caching for end user requests with minimal configurations by the customer. Finally, the AWS region concept raised the previous task, provide an ability to geo-distribute workloads by strategically deploying applications workload in regions that are anticipated to have high end user traffic. AWS DNS service Route 53 allow customers to route traffic based on traffic geolocation in combinations with EC2 Elastic Load Balancer or ELBs. This can allow AWS customers to ensure they're serving non-static resources with as little latency as possible. Answer the question, what continent has no AWS region? Antarctica. What country has its own partition? China. Alright guys, almost done. Let's keep going. Operational expenses and capital expense. Cloud, a business solution. While this course is focused on security associated with AWS, it is important to understand the business value of cloud versus on-premise database. After all, companies only use technology so that they can make money. A key concept to understand related to the business value of the cloud is the notion of capital and operational expenses. Capital versus operations. Capital expenses versus operational expenses. In business, a capital expense is a major purchase of goods or services intended to be used by the company over a long period of time. In contrast, operating expenses are expenses incurred as a part of day-to-day operations. In the past, organizations were known to pay in excess of 1,000 per square foot for data center build out and configuration. Using that pricing, a 1,000 square foot data center would cost about $1 million US. With the expensive nature of data centers, cloud providers saw an opportunity to create different approach. Essentially, every wasted compute cycle represents poor investment dollar spent. The inefficiency was dramatic when calculated across the industry. At hyperscale, as cloud provider environments are cost and operation efficiencies are inherently relative to any specific company building data center for internal company use. Cloud allows a pay-as-you-go and reserve capacity model for better manage IT expenses relative to the organization's IT needs. Furthermore, cloud highly optimizes workload for efficiency, bin packing, virtualizations management, networking tricks, etc., resulting in a more efficient operating cost that can be passed on to end customers. Finally, on spending money on assets like that are currently in use and has the advantage of enhancing operational agility, rather than be committed to the sunk cost of the capital expenses. Cloud providers allow organizations to change the size and types of technologies in use based on today's business needs, not based on the decisions made 5 years ago by a different group of business and IT leaders. It is a major purchase intended to be used by a business over a long period of time, a capital expense operation. Capital expense. API mandate and the two-pizza team. Even prior to the formations of AWS, the CEO of Amazon, Jeff Bezos, issued a mandate across Amazon that internal teams would be required to make their data accessible to all other teams via a service interface (API). As the legend goes, the specific mandate stated the following: all teams will henceforth expose their data and functionality through a service interface. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communications allowed, no direct linking, no direct reads of another team's data store, no shared memory model, no backdoor or whatsoever. The only communications allowed is via service interface calls over the network. It doesn't matter what technology they use, HTTP, Cobra, PubSub, custom protocols, doesn't matter. All service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to export the interface to developers outside the world. No exception. Anyone who doesn't do this will be fired. Thank you. Have a nice day. Bezos. This integrated approach to data management provided the key to AWS early success. It turned out that creating standardized API to interact with AWS services and resources is the key capability to unlock automations for AWS customers. Because teams always had to plan for external customers for use their services, customers rapidly benefit from the unique capabilities AWS develops. Any customer who interact with AWS services are ultimately interacting with the services APIs. In many cases, the very same APIs that AWS employees use. The two-pizza team. Jeff Bezos commonly encourages his perspective across AWS with both positive and negative effects. Another such example is the two-pizza team. Two-pizza team rule. Bezos famously stated as claiming, "We try not to create teams larger than can be fed by two pizza." The reasoning cited that smaller teams foster collaboration. While it is true that this collaboration likely led to much of the innovation we appreciate from the AWS today, it also had another effect. AWS has over 300 services today, and each of those services is run by a different team. When developing API and API naming conventions, consistency is key to usability for end users. Unfortunately, with the various AWS team, there is a lot of variety in the naming conventions of AWS service APIs. When using services that may have similar capabilities, end users can rely on those APIs being consistently named. With the need to be precise with programming grammar, these inconsistencies can leave developers frustrated and extensively digging through service documentations. Okay, answer the question: who announced the API mandate at AWS? Jeff Bezos. Alright, free open source capabilities, a built-in advantage. When you use AWS, you can have access to a large number of servers pre-configured to get you up and running quickly. Whether you need a website, a database, or a continuous integration, continuous delivery pipeline. AWS already has capabilities to ready to go for you. But beyond the services themselves, AWS has made large contributions to the open source software OSS space. These contributions include a wide variety of tools to enable AWS services, along with the pre-built solutions to general business IT problems. To use an example, CloudFormation is an infrastructure as code (IAC) service that allows users to deploy complex resources in an AWS account using predefined YAML or JSON templates. Beyond providing the service itself, AWS provides reference implementations and sample templates for various AWS services that users can check and customize or adopt as is. This goes so far as to include a fully functional airline booking application developed by AWS that you can deploy in your account. So if you happen to start your own airline, you can be up and running in no time. Service tool. One notable type of OSS or open source software is ecosystem tools. Ecosystem tools are tools that AWS has created to help users with the AWS service ecosystem and include things like AWS Data Wrangler, advertised as Python Panda for AWS services, AWS Shell, integrated AWS CLI, and AWS Lambda Power Tools Python, enhance AWS Lambda functionality. As these tools and capabilities are not widely advertised, AWS customers might not be familiar with many or all of their capabilities. However, as an AWS user, you should research and be aware of AWS services and example code before attempting to develop custom capabilities. Alright, that's such a long one. What is a AWS native infrastructure as code tool? CloudFormation. Serverless and other low-code solution. Genesis of serverless. When AWS created S3 Simple Storage Service in 2006, few could have foreseen the shift in approach it would facilitate. Services like S3, an object blob storage service, DynamoDB, a database service, and SNS, a notification service, dramatically reduce the effort spent on initial configurations and ongoing management of IT infrastructures. Serverless also has the benefit of little to no operational cost when idle. This means that if users are accessing your applications and performing activities, you can incur significantly less cost. Less cost than with servers running at the same cost regardless of use. These benefits were immediately clear. However, the serverless capabilities that AWS had brought into existence since then provide integrations and capabilities that would be hard to foresee back in 2006. Today, organizations that use AWS have access to a wide variety of serverless services with a vast range of support tools and reference implementations. For a developer, there are a few ways to go from an initial idea to a functional, scalable, and publicly accessible applications faster than using AWS serverless capabilities. Low-code, no-code solutions. Beyond pioneering a wide range of serverless capabilities, AWS also developed low-code, no-code services. These services allow developers and in some cases, users without programming skills to develop custom code and capabilities within AWS minimal configuration. AWS Honeycode is an example of a pure no-code solution, offering a drag-and-drop interface for building web applications and starting websites. AWS Amplify requires a bit more technical skill, but has become very popular for allowing developers to quickly build mobile and web applications. These types of services offering include a wide variety of other services beyond web and mobile applications. Services such as AWS Event Bridge allow AWS customers to build new applications and integrations based on custom or pre-existing application workflow. While still in the early stages, AWS and other cloud providers are working together to create software development workflows that don't inherently require programming skill. Answer the question, does service cost more or less than when running idle on traditional services? Of course, it costs less. And that's it for the reading material today. Let's get to the activity. Summary. During this room, you have learned some history about cloud technology and the basics benefits of using cloud. You should now understand how technology limitations in the 1990s and the 2000s drove the development of cloud technologies. How capabilities associated with reliability and scalability are hallmarks of cloud service providers. How cloud companies may see cost and IT agility benefits from using the cloud. How an API-first approach was powerful and also had drawbacks. How AWS provides various services, capabilities, code, and documentation for free. This background knowledge should serve as helpful context as you further explore the cloud technologies, specifically AWS. Okay, let's do the site. Let's see the activities. Instructions. You have been tasked to develop social media interaction website where users can communicate with each other with features more or less equivalent to those on Twitter or Facebook. You are tasked to get input from the teams, preparing feasibility report and present it to the CEO. You will visit each department and will be asking certain questions. You will be only given 30 seconds to answer each question. In case of running out of time, you get a penalty. Your game will be over after 3 penalties. Okay, let's get started. We have software engineer, DevOps, finance, and CEO room. Okay, software engineer. The software engineering team mentioned that the complete team is housed in California, in the USA. Therefore, they need a high availability server in that region. In case AWS is selected as a cloud service provider, what would be the naming convention for that region? US. Which of the following servers will be used to route traffic based on user geolocation? Route 53. In line with Japanese model at Amazon, each developer of our software team will expose the data to other members through a service interface called API. That's software engineering room. Now this is DevOps rooms. The website will be accessible from all over the world. Shall we deploy all the infrastructure on-premise or go for cloud services? Cloud services, of course. What is the most practical reason for selecting the cloud services model? Well, it has less latency rate for website users and easy scalability as the user base grows. Yes, this one sounds to be the correct one. On-premise infrastructure cannot be hosted. No, it's wrong. On-premise solutions have security risk. They both have security risk. So this one should be the answer. Finance group. The payment will be made to cloud service provider as a pay-as-you-go model, and the infrastructure will be expanded per the needs. Which of the following expenses is optimally used in this case? It should be optional. Why? Because the service is a pay-as-you-go model, meaning that sometimes you may not be using the services, so the cost is optional. CEO room. Okay, so this is the report that we are presenting to the CEO. Let's see. This is a question. This is our answers. Okay. All right, that's it. We get a flag. Yay! Congratulations, you've completed AWS Cloud 101. Thank you. So that's it for the room today. I hope you learned something about cloud, AWS Cloud. For those of you who have never worked with the cloud technologies, I hope this room is informational. And for those of you who have already been working with AWS, I hope this is a fun reading room for you to refresh your knowledge of AWS. And thank you very much. If you have any question, feel free to reach out and ask me. All right, see you next time. Bye.